for dropping by during my office hours. Today, we will discuss how to estimate water demand for a proposed development. Basic requirements. For any proposed development, proponents are required to furnish the city with anticipated figures for average daily, maximum daily, and peak hour water demand. It is imperative that all underlying assumptions be clearly articulated and comprehensively documented. Additionally, the water demand calculations must bear the stamp and signature of a licensed professional engineer authorized to practice. Estimating often requires calculations for 4 distinct water demands. 1. Average day demand, or ADD. ADD equals to daily average water demand. This value can be estimated based on the data of total water production over a complete year divided by the number of days in this particular year. 2. Maximum day demand, or MDD. Most of the time, MDD equals to 1.5 times ADD. The 1.5 here is called the peaking factor, typically ranging from 1.5 to 2.5. 3. Peak hour demand, or PHD. PHD equals to 2.5 times ADD. Like the peaking factor for MDD, the 2.5 here is also a peaking factor, typically ranging from 2.5 to 5.0. The determination of peaking factors is difficult without a formal demand study. However, a formal demand study requires daily and hourly customer metering data which is not readily available based on the daily operations of the utility due to the current customer metering technology. As such, the peaking factor assumptions from 2 or more fiscal year rate proceeding were evaluated using the methodology outlined in Appendix A of the American Water Works Association Manual M1, Principles of Water Rates, Fees and Charges. This method is also known as the Appendix A methodology. The Appendix A methodology develops estimates of peaking factors based on the system peak demand data, customer billing data, and adjustments for weekly usage and maximum hour to maximum day usage patterns by customer type. 4. Needed fire flow, or NFF. Many municipalities are willing to bear the increased cost of sizing distribution systems due to the potential reduction in losses achievable through utilizing the water system for fire protection. An ample supply of water can effectively cool a fire. The generated steam can starve the fire of oxygen. In situations involving miscible or dense fluids, water can disperse the fuel. The central inquiry for water utilities pertains to determining the necessary size of distribution system components to ensure an adequate water supply for fire protection. The NFF represents the required flow rate to effectively manage a significant fire within a specific building for a defined duration. Its purpose is to evaluate the sufficiency of a water system, forming a component of an insurance rating schedule. While not designed as a criterion for system design, practical demonstrations have shown that the NFF often aligns reasonably well with the actual flow needed to suppress a fire in real-world scenarios. In our next video, we will delve into a detailed discussion on calculating the NFF for a specific building. The available fire flow must be assessed at a residual pressure of 140 kPa or 20 psi during maximum day demand MDD. Finally, with all these calculations above, how do we estimate the water demand for a given proposed development? To conclude the water demand estimation for a proposed development, it is necessary to compare the sum of MDD and NFF against the value of PHD. The higher value in this comparison will be adopted as the water demand. For example, if MDD is 10,000 gallons per minute, NFF is 15,000 gallons per minute, and PHD is 20,000 gallons per minute, then the sum of MDD and NFF would be 25,000 gallons per minute. This value surpasses 20,000, therefore making the estimated water demand 25,000 gallons per minute. Thank you for tuning into this video. If you have any questions or specific civil engineering topics you'd like me to cover in future videos, feel free to leave a comment below. Your likes and subscriptions motivate me to create more content, ensuring you don't miss out on future updates.